Alright guys, using the AirPods with the microphone led me to having a mental breakdown because the microphone keeps dropping out and the video just keeps stopping recording at random times. Last time I just spent 20 minutes on solutions and it didn't record it at all because if I don't stop it before it stops recording, it just doesn't keep the video. I'm so over that. So, yeah. I'm just going to smash through these because for me this is the third time. Okay, so we've got y equals e to the 3x, so dy dx is just going to be 3 e to the 3x, which means x equals 2. We've got 3 e to the 3 times 2, which is 3 e to the 6, which on your calculator is 1210.29. For b, we've got dy dx equals negative 2 e to the negative 2x, which means x equals 2. We've got negative 2 e to the negative 2 times 2, negative 2 e to the negative 4, calculator. Now, what I've just done, the negative 2 e to the negative 4, that's actually the exact value, because in a calculator you could never get all the decimal places because e is irrational. Transcendental? Irrational, whatever. So this is going to give us 3 on 2 e to the 3 on 2x. We're going to end up with 3 on 2 e to the 3 on 2 times 2. So it's 3 on 2 e to the 3, which calculator 30.13. Question 7. E to the minus x. We're going to end up with negative e to the negative x. The negatives are going to cancel out for the next one if we derive that. So it's going to be negative e to the negative x times negative 1. So we're going to have positive e to the negative x. This one we're going to end up with negative e to the negative x again. This one we're going to end up with positive e to the negative x. So the pattern, it oscillates between e to the negative x and negative e to the negative x. Okay, next one. This is going to be 2 e to the 2x, 2 e to the 2x. We're going to times that by 2 again, so we're going to end up with 4 e to the 2x, 8 e to the 2x, 16 e to the 2x. It doubles each time. E to the x, we've got e to the x, e to the x, e to the x, and e to the x. Always e to the x. If we had y equals this thing, then y dash is going to be e to the x plus 2x plus 1. Y dash dash, we've got e to the x plus 2, and that one disappears. Third derivative, e to the x. Fourth derivative, e to the x. The x squared plus x plus 1 disappears. Alright, question 11 for advanced, but 8 for extension. Each of these we're going to do them individually, so f dash x is going to be 5 e to the 5x plus 7 e to the 7x. This one, f dash x, we've got 4 e to the 4x plus 2, 8 e to the 5 plus 8x, because remember, we're timesing it each time by the derivative of the power. This one, we're going to end up with negative 4 e to the negative x, and we're going to have negative 12 e to the negative 3x, because it'll be 4 times negative 3, negative 12. This one, the derivative of this thing is negative 2, so 6 times negative 2, negative 12 e to the negative 2x, take 3. Derivative of this one is negative 6. Negative 7 times negative 6 is positive 42, e to the 5 takes 6x. This one, 10x for 3e to the minus x. It changed to a plus because we timesed it by -1. Last but not least, we've got half e to the half x plus x to the half becomes half x. Half take 1 is -1/2. So if we wanted to be fancy, we would write that as e to the half x plus root x. Oh, it's -1/2. No, don't worry about that. We're not going to be fancy. I'm not fancy. You ready? No. Okay. This is advanced question 13. If you're after question 12, it's below. Each one as a simple power of e. So if it's e to the x square root, we've got e to the x to the half, which means e to the half x, and then differentiate it. Which means the derivative is half e to the half x. Write your answer without fractional indices, so it's half root e to the x, so it's e to the root e to the x on 2. Alright, this one is e to the third x, so dy dx is a third e to the third x, which is the cubed root of e to the x on 3. This one, we've got e to the -1/2 x. So when we differentiate it, we've got -1/2 e to the -1/2 x, which means we've got -1/2 root e to the x. Last one, this is e to the -1/3 x. So dy dx, -1/3 e to the -3 x. So we've got -1 on 3 times the cubed root of e to the x. All right. Question 12 for advanced, 10 for extension. So advanced, sorry I did this in a different order. Also for advanced, you only need to do a, b, c, d. Let's differentiate these. It's going to be e to the ax times a. Because we've got e to the ax times the derivative of the thing. So how did I write that? Y dash. This time we've got e to the minus kx. We're timesing it by the derivative of this one, which is -k. And so you just chuck it out the front at the start. This one, it's e to the kx, but we've got that a, so we've got a k e to the kx. Or ka e to the kx, doesn't matter. All right, this one, the derivative of this thing is just going to be p. This one, the derivative, we've got c times the derivative of this one, p e to the px plus q. This one, we're going to have everything on r anyway, but for e to the px, we've got p e to the px. For e to the minus qx, we've got -q e to the minus qx. And for this one, we're going to have e to the ax, so we've got a e to the ax on a plus -p e to the -px on p. We're going to have e to the ax take e to the minus px. So the a's and p's cancelled out. Okay, what else do we need to do? So this is question 15 for advanced, question 11 for extension. And so this is actually really easy. It's a weird concept. So if we have, I'm going to do it over here, y equals e to the 5x, dy dx is 5e to the 5x, isn't it? But we just said y equals e to the 5x, so we can replace that e to the 5x with y. Same here, we've got y equals 3e to the 2x. dy dx is going to be 2 times 3e to the 2x, or 3 times 2, it doesn't matter. Again, that is just y, so we've got 2y. And here, same thing, we've got y equals 5e to the minus 4x, so dy dx, we would have just ended up timesing that by negative 4, which again is y, and we're done. That's literally it. Last one, it's question 16 for advanced, which I don't think I set you. For extension, it's question 12, which I definitely did set you. Well, as it's the challenge question. We're looking at the hyperbolic cos and hyperbolic sine. So this is, I had a teacher at uni pronounce it kosh, but yeah, you would say cos h or kosh. Honestly, you probably won't say it. Show that dy dx. Okay, so if we have y equals cos x, which is e to the x plus e to the minus x over 2, then dy dx is going to be e to the x take e to the minus x on 2, which is the same as that. Okay, if we have y equals shine, that's how we pronounce sine hx, this time we're going to have the opposite thing happening. We've still got our e to the x, but we've got minus e to the minus x, it's times minus 1, so it becomes plus. Find the second derivative of each function. So d squared y dx squared, that's just how you write the second derivative. This time we're going to have e to the x take e to the minus x times negative 1, which is again cos. Here we're going to have e to the x plus e to the minus x, but it's times negative 1, which is again shine, the hyperbolic sine. This is what it started off with, this is what it started off with. Question C. So what they're saying is cos squared x take sine shine squared x equals 1. So this is saying e to the x plus e to the minus x on 2 squared take e to the x take e to the minus x on 2 squared equals 1. So we're just going to have to play around with this. We've got e to the x plus e to the minus x squared on 2 squared is 4. I'm going to multiply through by those 4s. So I've got e to the x plus e to the minus x squared take e to the x take e to the minus x squared equals 4. I'd like to remind you that if you ever have a squared take b squared, then that's a take b, a plus b. And I think that's going to be easier. I mean, technically I could expand both of these. No, I'm just going to expand them both. So this left one expands to e to the x squared plus 2 e to the x e to the minus x plus e to the minus x squared. I need much more room. Minus e to the x squared, take 2 e to the x e to the minus x plus e to the minus x squared. The whole thing should come out as 4. So we've got e to the 2x plus 2, e to the x times e to the minus x is e to the 0, plus e to the negative 2x, because you multiply the powers, take e to the 2x plus 2e to the 0, take e to the minus 2x. So we've got e to the 2x, take e to the 2x, e to the minus 2x, take e to the minus 2x, 2e to the 0, we've got 2 plus 2. And we're done. And I believe that was the last one.